Okay, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're doing for this kind of next section here is that we are doing kind of a we're basically answering some problems, and we're answering some frequently asked problems by kind of questions that are submitted by students like yourselves at home. What we're doing at OneClass is we're kind of creating these videos, creating these streams for the teachers to kind of verify these solutions. So we're given these problems here, we're given some solutions, and we're trying to figure out if they're correct or incorrect. And doing so, we're teaching you the concept behind the question so that you're ready to kind of prepare yourself for either upcoming test, or if you're looking ahead to kind of study further ahead in higher level math or chemistry as well. So again, my name is Joey. I'm currently an Ontario school educator in based in Markham, and what I'm doing here is I'm given these questions here, and again I'm verifying the solution. I'm trying to teach you the concept through that as well. So currently for the next hour I have about 11 questions, and these range from basically algebra 1 or the end of algebra 1, algebra 2, and pre-calculus questions. So without further ado, let's get started on today's problems. So what we have here, the first question of the day asks 2 oranges and 5 lemons cost $2.95. So again, we're given some type of word problem here. So let me write this out. So again, it says here, so 2 oranges and 5 lemons. So I'm gonna write that down. 2 oranges and 5 lemons, dude. Two oranges and 5 lemons. 5 lemons, sorry about that, cost $2.95, and then 3 oranges and 2 lemons cost $2.50. How much would 5 oranges and 3 lemons cost? Okay, so we're given these things here, so we're looking at these equations here, and we're trying to solve them. So let me think about this problem here. 2 oranges and 5 lemons cost $2.95. 3 oranges and 2 lemons cost $2.50. So basically what we're going to have to do is we're going to have to create some type of algebraic expression, right? So we have 5 lemons cost 2 oranges and 5 lemons cost $2.95. So we can say let's say let oranges, or let the cost of oranges equal x, right? Let x equal cost of oranges. Cost of oranges. And I'll let y equal cost of lemons here. Cost of lemons. So we can say that through our first statement here, 2 oranges and 5 lemons. So therefore we can say 2 oranges, which is 2x, plus 5y, we have 5 lemons, 5y equals $2.95, right? So it equals $2.95. And then from our second statement, we have 3 oranges, so 3x, plus 2 lemons, which is 2y, equals $2.50, right? So we're given 2 equations, given 1 and 2 equations here. And what we're going to do here is we're going to first, we want to find out how much would 5 oranges and 3 lemons cost. So we're looking at this problem here. So basically, if we want to find this problem, we have to figure out the unit price, or how much does 1 orange cost and how much does 1 lemon cost, and then we can solve for this solution here. So we're given equation 1, equation 2 here. What we're going to do is we can either two things. We can use substitution or elimination for us to get rid of a variable here. So in this case, I'm going to do substitution. So I'm going to use equation 1, and I'm going to basically I'm going to rearrange the solution to solve for a variable. Let's say I'm going to solve for x in this case. I'm going to rearrange for y. So I have 2x plus 5y here. So I have 2x plus 5y is $2.95. And then what I have here is I'm going to move 2x to the other side. So 5y equals $2.95 minus 2x. And then I'm going to divide everything by 5, right? So y here equals $2.95 minus 2x here all over 5. And this here is going to be the rearranged format for for equation 1. And what I'm going to do is I'm going to say sub equation 1 into equation 2. And then in this case, what we're doing here is we're placing everything in terms of x. So everything in terms of the cost of the oranges here. So we're solving for the cost of the oranges first. So I'm going to write here sub into equation 2. So I'm subbing this y equation to equation 2. So I'm going to have 3x plus 2 times whatever this guy is. So 3x times 2, so 295 minus 2x all over 5 equals $2.50. And now I have everything in terms of my x, right? So I can just simply expand this and solve for my x value, right? So I have 3x here plus 2 times 295 here would give me, let me use my calculator, 2 times 2.95 would give me $5.90. Minus 2 times 2x here is 4x here, all over 5, right? And this would equal $2.50. If I want to get rid of the denominator here, I can multiply our entire equation by 5, right? So I can multiply this side times 5 here, and then this side times 5 here. So in order for me to get that, I get 15x here, plus this cancels out, plus 5.90 minus 4x equals $2 times $2.50 times 5 here give me $12.50 here. And then what I can do now is I can simply collect like terms, right? 15x minus 4x here would give me 11x plus 590 equals 1250. And I can move 590 to the other side, right? So 11x equals whatever 1250 minus 590 is. So 1250 minus 590 would give me a value of $6.60. $6.60. And I can divide both sides by 11, right? So divide by this 11, divide by this by 11, and I would get x here would equal, this here would equal 60 cents, 0.60 cents here. So again, this is the cost of my lemons here. And then what I can do now is find the cost of my, these are the cost of my oranges, because I said x is oranges. I can do the cost of my lemons now. So I can sub this into this equation here, right? So I'm going to rework this and say, let me put here, so I know that y here, therefore y would equal my, let's see, I'm taking this formula. So 2.95 minus 2x all over 5. So I have 2.95 minus 2x all over 5. Yes, I got that correct, yeah. And then what I'm going to do is I'm going to substitute this x value into this equation to solve for y. So y equals 2.95 minus 2 times 0.60 all over 5. And this here would be equal y equals, oh sorry, this is kind of messy here. This is 2.60. So I have 2.95 minus, this is $1.20 all over 5. And then I can simply do y equals, so I have 2.95, oh, sorry. Dropped my calculator, 2.95 minus 1.20 divided by 5, and this would give me a value of 0.35, right? 0.35 here. It's 35 cents. So therefore, my cost of lemons is 35 cents, and the cost of oranges are 60 cents. And then the question was asking, finally, I can solve for my question now. The question's asking us, how much would 5 oranges and lemons cost, right? So again, 5 oranges would be 5 times x, plus 3 lemons, which is 3 times y, equals some value. How much would it cost, right? So I know that 5 here now, x, we solve for this x value. This is equal 60 cents. This is 0.60 plus 3 times y here is 0.35 equals some number. And then 5 times 0.60 is $3 here. $3 plus 3 times 0.35. Believe it's $1.05, and this would equal here $4.05 here. So this here is my solution to the problem. And this here is, I don't think they actually wrote the solution to the problem. So the solution here is actually incomplete because they only gave me the cost of the orange and the lemon, and they didn't give me how much would 5 oranges and 3 lemons cost. So, but this one's correct, but they showed the exact same amount of work for this 0.60 here, which is x, and y is 0.35 here. So their work here is correct, but their solution is just incomplete. So I'm going to say here, solution is incomplete. and needed to find cost of 5 oranges and 3 lemons. Here, right? Yes, 5 oranges and 3 lemons. So therefore, at 5 times 0.60 plus 3 times 0.35, and this would equal $3 plus $1.05, which would equal $4.05. The total cost of 5 oranges and 3 lemons is $4.05. So this solution, I'm gonna say it's incorrect just because they didn't complete the solution, but all their steps here were correct because they matched the same thing as I did here. That was number 1. Number 2 is asking what is the derivative of x sine x. So this is obviously a calculus question. We're finding the derivative of something. So I'm going to say that f of x here, I'll say let f of x here equals x sine x. And all we're going to have to do is find f prime of x, right? So I want to find the derivative of this function here, which is x times x. So in order for me to do that, I'm using the product rule, right? So again, I know that x here, I'm finding the derivative of the first guy here. So the derivative of the first guy here is 1 times sine x plus I have x here and the derivative of sine x. And we know the derivative of sine x here is cos x, right? So x times cos x here. So simply if I were to, I know this is my product rule, right? I'm simply just taking the derivative of my first function here. So actually, let me not use f of x here. I'm going to use another notation. Maybe I'll use h at x here, and this is h prime at x. So I'm going to say that this here is f of x, and this here is g of x. So I'm splitting the function into two. The first function here is x, and the second function here is sine x. So basically what I'm doing is I'm taking the derivative of the first function. So this here is 1 is f prime of x times g of x plus, and then x here would be, I get f of x here, times the derivative of the second function of g of x, right? And this here is something called the product rule. So this here, what I stated just now, f prime of x times g of x plus f of x times g prime of x here is the product rule. So this guy here is the product rule. It's our derivatives. So when we're finding the derivative of something times something of x times g of x, it's going to equal this function here, which means h prime of x, or just the derivative of x times sine of x, would equal just simply 1 times sine x, so that's sine x, plus x times cos x. And this here is my solution for this problem. So the derivative of x times sine x is simply just sine x plus x times cos x. And I believe that they got the question correct, right? They have derivative of sine x plus derivative equals sine x plus x cos x. So this here is the correct solution. So what they did here was they did a chain rule, which is basically the product rule, and they did. So this is a bit messy because of the formatting, but let's see. I have d of f of x times g of x over dx equals the product rule. So what I wrote here. So he said f of x equals x and g of x equals sine x, which is good. So derivative equals simply 1 times sine x, which is here, times cos x times x here, which is equal to sine x times plus x cos x. So solution here is correct. Good analysis, but could use better formatting, is what I would like to say for this problem here. Solution here is correct. Number 3 is asking us find all the real fourth roots of 625 over 2401. So I want to find the real fourth roots of, and then it's 625 all over 2,401 here. Okay, so I'm trying to find this value here. I'm trying to find the fourth roots of this guy here. So basically what I'm going to have to do is I can either think of this as this entire fraction to the power of 1/4. So that simplifies to 605 to the 1/4 over 2401 to the 1/4. Or you can say it's the fourth root of 625 divided by the fourth root of 2401. So these are all kind of notations that you should be familiar with in terms of the fraction with exponent changed to a square root or some type of fourth nth root, you can say. So what we have here is some type of fourth root, right? So in this case, what I want to do is I would basically use trial and error in this case. So because we don't really memorize fourth roots, so we can say that this guy here, this first one here, just by inspection, I'm looking at 625. The factors are either 5 or 15, right? Because again, it ends in 5 here, right? So let's try 5 here. So if I have 5 times 5 times 5 times 5, would that equal 625? So let's check. 5 times 5 is 25, times 5 would be 75, times another 5 would be indeed 625. So I know that the numerator here is going to equal 5 all over. And then finally, and this here is plus or minus 5, right? Because if I'm taking the square root here, I should get plus or minus 5 here. And then finally, this one here would be 2401. I don't think it's divisible by 3 here, because if I'm adding the digits here, 2 plus 4 is 6, plus 0 is 6, plus 1 here is 7, so it's not divisible by 3. So let me try. 1 doesn't work, 2 doesn't work because it's an even number, 3 doesn't work, 4 doesn't work because it's not an even number, 5 doesn't work because it ends in 1. I'm going to try 6 here. So 6 times 6 times 6 times 6 would give me 1296, so that's not correct. And then I'm going to try 7. No, 7 times 7 times 7 times 7 would give me 2401 here. That's the number I want. So therefore, this would also be plus or minus 7 here. So this solution here is, this is going to be our solution here. And we want the real roots, right? So I can actually ignore all the complex roots that, that have to deal with these guys here. So I can ignore, let me do this in red here, because these are just my real roots, right? I also have technically, if we were to include the complex roots in this problem here, we also have plus or minus 5 over 7 times I here, and we don't really need to know the complex root here, because it's asking just for the real, right? Just for the real fourth roots. So therefore, this is neglected because complex. Because it's complex. So I'll just say it's because complex here. So basically, we're just looking at this guy here, and then all we have to do is sorry, it's just plus or minus 5, 7, right? So therefore, my real roots of this problem here is simply just 5 over 7 and negative 5 over 7 here. So these two are the real fourth roots of this problem here, and as you can see, this here is the correct solution. So basically did the same thing as I did when they did trial and error, because we don't really memorize fourth roots as a mathematician or as any human being, to be honest. So what we're doing here is this is 625 here divided by, this should be 1 divided by 4 is going to equal plus or minus 5 over 7, and this here is correct. So the solution here is correct. I like how they negated the complex root as well. Solution is correct. Good analysis. Okay, that's number 3. Number 4 is asking us, how do you evaluate arc sine half? So let's see, 4. So this is evaluate arc sine of half here. So what we're gonna have to figure out here is, we are figuring out, again, we're just it's knowing this this concept of trigonometry, right? And how do we know this is simply just a trigonometric problem, and probably what you see in algebra 2 in grade 11 here. So what we know here is to evaluate arc sine of half. So basically, when we're talking about arc sine here, this is simply just the inverse, right? So we can also rewrite this as, my pen works here. We can also rewrite this as arc sine here is simply just the inverse of sine times half, right? So this here is also, we can also rewrite this as the sine, the inverse sine, right, of half here. So in terms of, now it's trying to evaluate, right? So if we're evaluating this here, what we're doing here is, you can either, there's two kind of solutions to this problem. You can, there's actually two solutions to the problem, just because whenever we plug this into our calculator, because we don't really do this operation by hand here, the inverse of sine of half, we plug this into our calculator. If you plugged it into your calculators in degrees, you would get a value of 30 degrees. So this here, so I'm going to write here, let me preface this here. So this here in degrees, or in deg, you would get 30 degrees. And in radians, you would get a different number here, which would be pi over 6. So this here is the first solution to the arc sine of half would be these. This is the first solution. This is either 30 degrees, or you could say it's pi over 6. However, we also have to use cast rule. We have to find cast rule. We have to use our cast rule to figure out where is the second solution, because there's always two solutions, or there could be two solutions when we're working with this. So let me just draw out the 4 quadrants for you on this side here. I'll do some blue because it's some side work. So what we have here is, this is AA, S, and T, right? So cast, C-A-S-T. And this here, we know that here is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? So we're working with the inverse of sine here. So the inverse of sine here is, and it's a positive value, right? So this here is 30 degrees. So again, I could say this here was 30 degrees. Again, I'm simply just sketching here, right? And we're asking ourselves, which quadrant is sine also positive? And as you can see here, quadrant 2, it says S, right, for sine. So again, this is the quadrant 1, all trig ratios are positive. Quadrant 2 is simply just sine. Quadrant 3 is tangent, and quadrant 4 is cosine, right? So in quadrant 2, sine is also positive, which means I'm going to get another value here. So if I have 30 degrees here, I can also get this this value here, right? This is also my angle theta here, and this will also give us our solution as well. And if I want to find this solution here, it's simply just, if we're using our simple geometric kind of values here, and our geometric identities, if we have a straight line, this is simply 180 degrees. We can subtract that by 30 degrees to get theta, right? Which is, so theta here would just simply equal 150 degrees. Or if you were working in radians, so this here is in degrees, right? This here is his degrees, so this here in degrees. And if I was working in radians, I can simply put, again, in radians here, I'm going to do this in red here. This is simply 0 and 2 pi. This here is pi over 2. This here is pi, and this is 3 pi over 2, right? So if I were to do it in radians here, we do this in red, I will have, it's simply just pi minus pi over 6 would equal theta, right? So in order for me to transfer this, I can write this as 6 pi over 6 minus pi over 6 here, which is equals theta. So theta here is simply just 5 over 6. 5 pi over 6. So this here is also my solution. So in this case, I have two solutions, or in this case 4 solutions, because I have solutions in degrees or radians. It depends on what the question's asking. So if I were to say my solution here is, so let me write this down. Let me write this over here. So therefore arc sine of half would equal, and I would write this in degrees. So in degrees, you would get 30 degrees and 150 degrees. And then in radians, you would get pi over 6 and 5 pi over 6 here. And these are my solutions for this problem here, 30 degrees and 150 degrees, and pi over 6 and 5 pi over 6, depending if they're asking for either radians or degrees here, depending on the extent of the question. And as you can see, the solution is correct. So answer within the interval of 0 and 360 is 30 and 150. They didn't include the radian solution here, so let me just include that, but the solution is correct regardless. So this shouldn't be analysis. If question was asking in radians, then solution would be pi over 6 and 5 pi over 6. So the solution here is correct. That's number 4. We can look at number 5 here. It's asking us find the area of the unshaded region of the circle with radius 6 units here. So number 5. It's number 4, right? Yeah. Okay, and then I'm going to use my circle tool to kind of draw this this kind of area for you out. So let's see. have a diagram here. It's asking me, I have some point of A, O, and B, right? So I'm going to say this is here as a center. So I have some point of A, some point of O, which is a center, some point of B here. And I have some sort of angle, and it's going to equal 120. So let me just draw this out. So this angle theta is going to give me 120 degrees. And I want to find, and this radius here is 6, right? So there's between AO, this here is 6. Maybe on black ends. So here's 6 meters, and this is 120 degrees. And I want to find the area of the shaded area. So we can say that this here is our shaded area, right? This here is our shaded area. So how do we find this area here? So in order for us to find this area here, what we're going to have to do is we're going to have to basically take the area of a circle, right? So we know the area of a circle here equals pi r squared, right? Normally. So an area of an entire circle is pi r squared, right? And this is a good starting point for how we figure out our solution, right? So here, the area of a circle, or in this case, if it was the entire circle, 360 degrees here, would equal pi r squared, right? However, I'm only looking at this shaded region here. So what percent of the circle would this make up? And I would have to look at this percent, and then I would have to look at this here and modify our formula here. So if 120, right? 120 degrees here, and in a circle, I have 360 degrees, right? So in circle, it equals 360 degrees, and currently I only have 120 degrees, right? So this here, I can safely say that this here is 1/3 of my circle, right? Because I could have another angle that would be another 120 degrees. So if I were to look at it, it'd be something like this, maybe. I don't know. It's hard to visualize here, just because I can't really cut this up in like 3 angles. I would probably have to. It'd be something like here. It'd be a line like this, and this is 1/3. This is 1/3, and this is 1/3. And although it's not accurate, here. It's not to scale here. These are supposed to be equivalent values here. So in a circle, it's 360 degrees. So if my shaded region is only 120 degrees, it's simply just 1/3, right? It's simply 1/3. So I can simply do 120 degrees by 360 degrees, and this here simplifies to 1/3. And this here is our magic ratio for us to change our formula, right? So therefore, I can say that area of the shaded region here, so I'm going to say area of the shaded region for S here would equal 1/3 pi r squared, right? Because it's 1/3 of the circle here. And now we can simply solve this problem here, right? My radius here is 6, so I can say that this here equals 1/3 times pi times 6 squared. 1/3 times pi times 6 squared is 36. And then I can say 1/3 times pi here, or so sorry, 1/3 times 36 here is simply just 12, right? So the area of the shaded region here is simply 12 pi. And this here is the correct solution. Or sorry, I want the unshaded region. Oh, I messed up. So, okay, that's fine here. So this here is the area of the shaded region. So this is the shaded region. So therefore, the area of the unshaded region, would equal the total area minus the area of the shaded region, obviously, right? And I know the total area here is simply just pi r squared, right? If it was the entire circle here. So let me just do some side work here. So area of the entire circle is just A equals pi r squared, pi times 6 squared here, which is simply just 36 pi, right? Pi r squared. So I can simply subtract 36 pi from 12 pi to get to my answers here. So area of the unshaded, which is what I want here, area of the unshaded region, right, is equal to the area total area here, which is 36 pi. So here's 36 pi minus the area of the shaded region here, which is simply 12 pi. So area of the unshaded region is simply just 24 pi square units. So this here is my solution for this problem here, 24 pi. And as you can see, they did the exact same thing. So they found out the area of the shaded region, and then it's going to add up to the area of the unshaded region to give me the area of the full circle. So solution here is correct. Go to analysis here. Okay, let's look at this next question here. It's stating, what is the quadratic equation and how do you derive the quadratic equation here? So this one's a bit trickier and in terms of deriving the solution, but I'll kind of walk you through the math as to how you would figure out this problem here, or how you would basically derive this problem, because your derivations usually take quite a bit of time. So I would and you're not really supposed to know derivations for mathematics, to be honest. If you're looking at high school math, you don't really not a lot of teachers would ask you how to derive the quadratic equation here. But asking us what is the quadratic equation, well, I know the quadratic equation, right? Something you probably should memorize given in a grade probably 10 context, end of algebra 1 and beginning of algebra 2. So I know the quadratic equation is simply just x here equals, because I'm solving for x, right? So depending on, and this is a quadratic equation, so it's simply ax squared plus bx plus c, right? It's some sort of, this is a general formula or equation for a quadratic function. And then there, if I want to solve for x here, x would equal negative b plus or minus the square root of b squared minus 4ac all over 2a here. So this here is my quadratic formula for quadratic equation for this formula here. And then it's telling us, how do you derive the quadratic? How do you get from this general equation to here? So in this case, I'm just to save me some time, I'm going to actually just look at the solution, and I'll show you in terms of mathematics what they're doing here. And I'll break this question down here. So if I have ax squared plus bx plus c, what they're doing first is they're dividing everything by a. And this here equals 0, right? Because it's a quadratic function here. So I'm dividing everything by a here to get this first step here. So let me just copy down what they're doing here. So if I'm dividing everything by a, right? So I have ax squared plus bx plus c equals 0. I'm dividing everything by a. So I'm dividing this entire function by a here, this left side here, this left side here. Again, the right side doesn't mean anything, it still equals 0, right? But then this left side is going to change. I have x squared plus bx over a plus c over a here. And then what they're doing here is they're adding and subtracting the square of the half of the coefficient of x here. So what does that mean? Well, that means that they are basically trying to complete the square. So they're thinking of what they're doing here is they're adding b over 2a squared minus b over 2a squared, right? So they're simply just trying to expand this so they get some type of perfect square trinomial for these two guys here. So let me write this down here. So x squared plus bx over a plus, and then I have b over 2a squared minus b over 2a squared plus ca equals 0. And then, as you can see here, what I can do now is I can group these guys here. Right? I can group these guys here because this is a perfect square trinomial, right? So I can say here that this is simply just x plus b over 2a squared, right? Which equals, and then I'm basically moving everything to the other side here. So I'm gonna have positive b squared over a minus c over a here. And then now what I'm doing here is what they did here was they expanded this bracket here. So I have x plus b over 2a squared equals b squared is b squared, 2a squared is 4a squared minus ca. And then what they're doing here is they're taking the square root of both sides, right? Because they're now isolating for this x value here. So we're going to square root both sides. So I get x plus b over 2a equals the square root of b squared over 4a squared minus ca here. So this here would give me the square root of both sides. So it's square root of both sides, and this is plus or minus, right? Every time I take a square root, it's plus or minus here. And then what I can do is I can simply subtract ba from both sides. I can subtract this guy to both sides, right? So I'm leaving x by itself, right? So x here is going to equal, this is now negative b over 2a. I'm moving this to the other side, right? To the right side here. And it's going to equal, this is plus or minus the square root of b squared over 4a squared minus c over a. And then finally, I can clean this solution up by saying that, this entire thing, what they're doing here is they basically just combined both these terms here, right? So they have here x would equal, this is still negative b all over 2a, but what they have here is they combine this these guys into the in the square root term, right? So they put it all into one common denominator, which is 4a here. So this is simply just plus or minus. This here is b squared minus 4ac all over 4a. And as you can see, what we can do here is we can just simply cancel out one of the 2a's here. So these cancel out here. So you have x equals minus b plus or minus the square root of b squared minus 4ac, and it's all over 2a here, because this here is going to be all over 2a here. So this here is how you derive the quadratic equation. Again, very, very long and very, very tedious, but that is basically what they're doing in this logic here. So this solution here is correct. Good analysis here. And again, derivations are quite hard actually. So even I'm not that comfortable with derivations, just because it's not really required until like until kind of proofs and upper level mathematics. Okay, let's take number 7 here. Define the function 213 is my function. I think there's there might be a formatting error, so I'm gonna maybe download this file and see if we can look at this problem better. So give me a second here. Yes, so this here is my function here. Let me try to increase the size here for you all to see. It's kind of blurry, but it'll work out here. So define the function. F of x equals, so I have f of x here. And I'll rewrite this because it's kind of blurry. Over x squared plus 3 here. And I care about, find the intervals for which f of x is increasing. So I want the intervals for which f of x is increasing here. So I'm going to cancel this. And then it's also saying I have this other image file. Let me download that quickly. And this is asking us find the points of inflection of y equals 5, y equals f of x. So I also care about the points of inflection of f of x. Okay. So this here is, again, calculus question as always. And what we're going to do is this is an incomplete solution here, but basically they had the right logic here. So let me just do this problem here. So it says here, I want the intervals for which f of x is increasing, right? So I'm going to take this function here, take f of x, and I'm going to find f prime of x here. So I have f of x equals 1 over x squared plus 3. So let me rewrite that. So this is a 2-part question. So here's part 1, part 2. So I'm going to start with part 1 here. So I have first f of x equals 1 over x squared plus 3. Was it x squared plus 3? Or yeah, x squared plus 3. So if I want to find the derivative of this function here, I can rearrange this first to find the derivative before I find the derivative, right? So I can say here, I can rearrange f of x here to equal, just to help me with my solution here, this would equal x squared plus 3 to the power of -1, right? This is exactly the same. I'm just putting it to the -1 to help me, so I can use chain rule. And then finally, what I can do here is I can take f prime of x, right? So f prime of x, the derivative of f of x would equal, again, it would equal I would bring down this -1 here. So I have -1 times x squared plus 3, and I would have to lower the exponent by 1 here. So -1 becomes -2 times the derivative of the inside. The derivative of the inside here is simply just 2x here, right? 2x. And then this here is the derivative of this function. I can clean this up by saying here, this would be simply just -1 times 2x. So I have negative 2x at the top, and it's going to be x squared plus 3 squared at the bottom, right? So this here is simply the derivative of my function here. So this here is the derivative of this function, which is great. And then I want to find the intervals for which f of x is increasing, right? So as you can see here, it says here the denominator is always positive, and that's correct, right? The denominator here is always positive. That's good. And what it's saying here is, therefore, the slope of the function f of x is positive increasing is when x here is less than 0, right? So this here is correct. So basically, when I want to find intervals of increase, I basically just set this guy here. I basically want a positive value every single time, right? So if I want a positive value for f prime of x, the intervals are going to be increasing here. So as you can see, I can set this to 0, or I can set basically x squared plus 3 squared to 0. And then you would realize that this here is always increasing when it's greater than, or when it's less than 0, sorry, when it's less than 0 here. So this here is, this is the correct solution for number 1, for part 1 here, for part 1. And I can actually do this for you. So let me just do this for you. So I have x squared plus 3 squared. I'm going to set this to 0. I can square root both sides. I would get x plus, I would just get rid of the x, the squared here. I can simply put x squared equals -3. And then if I were to square root this again, I would get an imaginary number here, right? So this here would not be valid here. But I can solve -2x here. I can set this to 0, and then if I divide by both sides here, x would equal 0, right? So again, this here is a valid solution. This here would not be valid because I would get a square root of a negative number, and this here would be a complex root here. So this, I would reject the solution, and I would basically look at the solution. So x equals 0 here would be my solution. I'm setting this guy to 0 for f prime of 0. So this here would give me my answer for this problem. Yeah, so I would have I would have this as my function. Actually, just give me a second. I think I have to actually set f prime of 0. So not setting it to 0, but I'm setting f prime to 0, because this would actually give me my minimum and maximum points. So this is actually, I'm actually setting it to 0. Sorry. So I'm setting f prime to 0. F prime. So I'm subbing this guy in. F prime at 0, sorry. So that's a major difference here. Equals -2 times 0, and then this is simply 0 squared plus 3 squared here. And this would simply equal 0 at the top. It doesn't matter what it is at the bottom. I think in this case is 9. This here still equals 0. So in this case, f prime of 0 is 0. So therefore, if it's less than 0, then it would be increasing here. So therefore, I can say x is less than 0 would f of x be increasing. And then finally, for number 2, the second part of the question, it's asking me to find the points of inflection, right? So let me scroll up for you here. I want to find the point of inflection. If I want to find the points of inflection, I have to find the second derivative here. So let me take my first derivative first. So this is simply this guy here. So let me rewrite this as it's -2x all over x squared plus 3 squared, right? So let me rewrite that. And that's f prime of x. So f prime of x is equal to -2x divided by x squared plus 3 squared, right? So I have this f prime of x, and now I want the f double prime, right? I want the second derivative of this function here. So let me write this smaller because I'm going to get a large thing here. Let's see, f double prime of x would equal, so I'm going to use my quotient rule. Right? I'm going to use my quotient rule to find the derivative of both this function here. So if I want to find, I'm going to use the quotient rule. So basically the quotient rule, it states here that I'm basically putting this guy here as f of x, and this here is kind of a g of x. So maybe I would actually use this. I'm going to label this as h prime of x, just to keep my kind of thing constant here. So this would equal, I have first g of x, so I have g of x here, so I have x squared plus 3 squared multiplied by f of x, or f prime of x, sorry, by f prime of x. This here is -2, right? -2, and then I'm going to minus the derivative of this guy here, right? Derivative of this guy here would be, I bring the 2 down to here, so this would be 2 times x squared plus 3, and then I would have times, this here is now 1, times the derivative of the inside, which is 2x here. I believe that's correct. I might have to use the chain rule here, so sorry about this. I might have to use the chain rule. So I'm gonna have to say, so this is actually a complex question because it's a chain rule within a quotient rule problem. So I would have to say basically, let u equals x squared plus 3. So therefore, I'm taking du over dx of u squared, right? U squared, which would equal 2 times u, which is simply just 2 times x squared plus 3 times the derivative of the inside, which is this 2x. So I think actually this is actually correct, actually. So I actually did the derivative correctly. So let me erase this guy. So I'm taking the derivative here. So again, I have 2 be x squared plus 3, and the derivative of the inside would be 2x here. And then this, I'm multiplying it by the negative, by f of x here, which is simply negative 2x. And this is all divided by gx squared. So this is simply just x squared plus 3 squared, and then squared again here. And basically, I want to set this guy, again, this here is my h double prime of x. I'm going to set this guy here to 0. I could simplify this before we do that, but it doesn't really matter. And as you can see here, if I'm setting this to 0, this again number can't be 0, so I basically care about this top part here, right? So I'm going to simplify this top part and say that I have -2 times x squared plus 3 squared minus, and then I'm going to have -2 times 2x here is -4x times another negative here would be positive 8x. Actually, I'm gonna separate this negative first. So I'm gonna do these guys first here. So -2 times x squared plus 3 times this here is -4x here, and this here would be -2 times x squared plus 3 squared minus this here would be -2 times -4 would be positive 8x times squared plus 3. And then if you look at these factors here, I can let's see, I can basically use FOIL and I can rearrange this to give me some sort of quadratic equation, right? So let's see. I can do that for you as well. So I have -2 x squared plus 3 times x squared plus 3 plus 8x times x squared plus 3 here. And then I'm going to have to use FOIL, right? So I have -2 times, basically this here is x to the 4 plus 3x squared plus 3x squared plus 9 plus 8x times x squared plus 3. And again, here I have now -2 times, this is x to the 4 plus 6x squared plus 9 plus 8x times x squared plus 3. And then finally, I can do this here equals -2. I'm basically expanding, multiplying the -2 inside the bracket. So -2 x to the 4 minus 12x squared. This is -18 plus 8. And then I'm going to expand this as well. So I have 8x cubed plus 24x. And then I'm going to basically just group them with like terms, right? I have -2x to the power 4. and then I have plus 8x cubed, and then I have minus 12x squared, and then plus 24x minus 18 here. And this here is my quadratic function, and I'm setting this to 0, right? This guy is going to equal 0 here. So I'm setting all of these guys to 0. So this here would just give me negative 18, right? And this here is my solution for this problem here. I'm just setting h at 0. Or sorry, I'm setting this entire function to 0. Sorry, not h at 0, but I'm setting this entire function to 0. So I'm solving for this this quadratic function here. So this here is not 0. Sorry, I'm setting this function to 0 here. And this here would give us, if I solved this quadratic function here, if I use factor theorem to solve for this quadratic function here, you should get x equals 1, x equals negative 1, and these two would be our correct answers here. So I'm just going to see what they're doing here. So this is multiplying both sides by x squared plus 3 cubed gives, and then you get something like this. But I don't think this here is a cube. This here should have been a squared here because I'm doing the quotient rule. So I don't know if this thing is correct here. Let me just use the quickly use the factor theorem and see if I can solve this problem for you quickly, so I don't have to use factor theorem for the sake of time here. So my first number here is negative 2, it's 8, then it's negative 12 plus 24 and negative 18 here. Let's see if I get some sort of solution. Yes, I do. So I get two solutions here. I have 4 solutions, but which 2 of them are real and 2 of them are complex here. And I'll write down the real ones here. So therefore, by factor theorem, I would get here, this is x minus 1 and x plus 3 here. And I get 2 more roots that are complex. So I don't care about these guys here. So which therefore I have this here is x equals 1 and x equals 3 here. And these 2 are my inflection points for this problem here. And they wrote x equals 1 and negative 1 here. So this here is not the correct solution to this problem here. So solution is incorrect. Inflection points are x equals 1 and x here equals 3. So, and then this is solved by using factor theorem on the second derivative of the function. So the solution here is incorrect. So I don't think I have enough time to go through the other ones because this here was a very, very long question. This was number 7 here. Yeah, number 7. Maybe I'll just try to do number 8 for the sake of time. I'll try to finish off number 8 here. Maybe I'll just look at the solution and kind of give help verify this. But it says here what number is needed to complete the pattern. So I have this pattern of 66, 73, 13, 21, 52, blank, and then 10, and then 20 here. So again, what they're doing here is, look at the solution. They're grouping these numbers by 2, right? So again, they're looking at these 2 guys here, and they're looking at the difference of these 2 numbers, which is 7. They're looking at this 2 difference here. Difference here is 8. Difference of 52 and some x here, and difference here is 10, right? So I have 7, 8, blank, and then 10. So therefore, this here has to be a 9, right? Just logically, this is a 9 here. So therefore, I'm looking here. This is positive 7. This is here is negative 8. This here is positive 10. So this here would be a this here would be, let's see. Oh, sorry. Actually, no, these are all plus 8s actually, because all the numbers are increasing here. So 66 plus 7 is 73. 13 plus 8 here is 21. 52 plus 9 would therefore be 61, and that would fulfill my pattern here for number 8 here. So again, 61 is the completed pattern. So missing number, which completes the pattern. So solution here is correct. good analysis here. So that's going to be my last question of the day. I know that calculus problem took a lot out of me and maybe a lot out of you as well, but this here was my solution. So I got the correct answer, which is great. Again, thank you so much for watching this video. Again, if you like this channel, again, definitely subscribe to the OneClass channel so you can keep up on the videos that I post. Again, my name is Joey. I stream from Monday, Wednesdays, and Fridays for mathematics and Tuesdays and Thursdays for chemistry as well. So again, as always, thank you so much for watching and have a great day. Stay safe, stay healthy, take care. See you later.